Because a to the negative first power and negative x to the negative first power is being subtracted, we can't just move them to the other sides without a little bit of manipulation. But actually, we can make this look just like what we did yesterday. If you remember that when we take a look at that a there, that very first thing, that a to the negative first power, we could rewrite that as 1 over a. Are we okay with that? It's on the wrong side of a fraction, so I could just rewrite it as 1 over a. And I'm going to do the same thing with x. I'm going to do it as 1 over x. Now I'm going to do the same thing with those negative exponents in the denominator. I see everything's got a negative exponent, so what I could do is I could go a squared, bless you, over x squared. Are we okay with what I did right there?
Yes.
Okay, so for whoever said no, I took the negative exponents and I put them in the denominator, just like we did with exponents before. When we have a negative exponent, it just means that we can move it to the denominator. So that's what I did, was I moved it to the denominator. So this became this, this became this became that, and this became that. The reason I'm doing that is because now I know this is just like we did yesterday. It's no different at that point. If I look at it as 1 over a minus 1 over x all over 1 over a squared minus 1 over x squared, then all I need to do is come up with a common denominator on top, combine them, common denominator on bottom, combine them, and then we'll work through this. So let's start with the top. What can I do with the top? Well, I can't just add something to them. If I'm going to subtract. Okay, so this one needs to be multiplied. Since there's an a and an x, this one needs an x on both top and bottom. And the other one needs a what? An a on top and bottom. So what we get is x over ax. I just put them in alphabetical order. I could have called it xa. It's the same thing. I'm just putting in alphabetical order to make it easy. Over here, I get a over ax. So now they have a common denominator, so it's totally okay to consider them one fraction, ax. And in the top, we would get x minus a. All I did was combine these two fractions here into one fraction. Now I'm about to do the same thing in the denominator here. I'm going to take away those circles there. Let's do the same thing in the denominator. Yes, ma'am? Okay. So what do I need to multiply, what do I need to do with the denominator to get a common denominator? Well, we don't have difference of two squares. They're in the denominators. So what we're going to multiply is by what's missing there. We get x squared over a squared x squared. I'm just putting them in alphabetical order there. You could have left it as x squared, a squared. I just like to put them in alphabetical order. We get a squared over a squared, x squared. I'm going to combine those two things. I've got x squared minus a squared over a squared x squared. So I realize it looks like a whole lot of mess right now, but actually we're in a really good place. Because what can I do now that I've got just one fraction over one fraction? Let's write it out. So what we've got here is, why is this not moving? There we go. We've got x minus a over ax divided by x squared minus a squared over a squared x squared. What's my next step? Keep, change, flip. X minus a over ax. Change to multiplication and flip this one over here. All right, any thoughts on what we could do now?
We can cross out the a squared and x squared. Wait, no, they're not the same order. Or does that matter?
I'm sorry, I got lost there for a minute. I thought I knew what you were talking about, but then you kind of lost me. Say it again. You might have been right. I'm sorry, I just got lost there for a second. It was me, not you. Go ahead. What did you say? Okay. So anybody have any thoughts?
Actually, break that down.
Break what down?
X squared and a squared.
Yeah, x squared minus a squared is the difference of two squares. What does it break down into? Okay, so we've got x minus a and x plus a. What now?
X minus a and then x minus a cancel out.
Good. This x minus a and this x minus a are going to cancel out. I'm just going to rewrite now. It's getting a little busy here. I've got 1 over ax times a squared x squared over x plus a.
We have a question.
Yep.
Could you do the difference of two squares on the top?
Well, there's no difference. There's no subtraction. Yes, if it were a subtraction, but there's not. So we can't do that. So talk to me about things being multiplied in the bottom left and the upper right. There's still something that can be done there. Bottom left and upper right. Yes, ma'am. Yes, ma'am.
You take out ax from the a squared and x squared, so it's just ax on top and then ax on the bottom becomes 1.
Good. So let's look at this right here. And they have a common factor of ax. They both have an a and they both have an x. And what would be left over inside is ax, right? Ax times ax would give me, we've got that right there. Why is that more useful than what we had? There's a common factor. A squared and x squared, they both have an a and an x. We can factor out an a and factor out an x. Like, look, all I'm doing is rewriting it like that. Ax times ax. A times a is a squared. X times x is x squared. Why does this help me?
Because you have to cancel out.
Cancel out one of those. So now we have an ax on top and an x plus a in the bottom. Final answer.
Then why can't you cancel out all three of them?
All three of what?
Like all three of the ax.
There is an ax on the bottom, and there are two ax's on top.
So that can you just
Why
cancel
can't you
both?
cancel?
You can't cancel out two of something with one of something. Just because, like, you can cancel one of the same thing with one of the same thing. It's just like this. Like, why can't I cancel that 3 out with the 9? The 9 is just 2 3s. Right? I can't cancel a 3 out with a 9. I can say 3 goes into 3 once, 3 goes into 9 3 times. I can do that. What we did here is we canceled one of the ax's with one of the ax's, leaving an ax over x plus a. Let's go on to number 2. Whenever I have these negative numbers in a fraction, one of the things that I can do is just rewrite them. So you're going to see the same pattern I'm doing each time. 1 over u squared minus 1 over v squared. That's the numerator. All I did was just rewrite the numerator. I took those negative exponents as I wrote them with positive exponents. Over 1 over u minus 1 over v. Again, all I did was rewrite the bottom. I took those negative exponents and wrote them as positive exponents. But if I'm going to combine these, I'm going to need a common denominator. Let's talk about the top first. What do I do to the top? Yes, ma'am.
Square on both sides.
What on both sides?
Like on top as well. And then the other side would be u squared.
Okay, and this one needs a u squared on top and bottom. So what we get is v squared over u squared v squared. I'm just putting it in alphabetical order. That's all I did there. That's the reason I switched them. U squared over u squared v squared. And then in the bottom, let's do the same thing. This one needs a v, and this one needs a u. So we get v over uv minus u over uv. And now we're going to combine those two fractions. U squared, v squared, that's our common denominator. And on top, we just have v squared minus u squared. In the denominator, we've got uv, v minus u. It'll take a second so everybody can get that written down, and then I'm going to move to the next line. So we've got v squared minus u squared over u squared v squared divided by v minus u over uv. And what's my plan for that? Keep, change, flip. Keep this the same. Change that division to multiplication and flip this one here. This one's going to work out very similar to the last one. Talk to me about it. Yes, ma'am.
For the u squared, v squared, in the bottom, do you want to do we can do u,
Okay, we can break it down into uv times uv. Same way we did the last one. What else?
and you would cross that out.
I don't have anything else yet. Like, there's still things to be factored. Let's do all the factoring first, and then we'll start crossing out later, or else this is going to get so much longer. Difference. Okay, for 3, we've got 1 over x minus 1 over x squared divided by,
Well, this is higher, and the other one is x squared as well.
oh, I'm sorry. It's not negative there. My apologies. Good catch. I was going too fast. That should just be minus x squared. My apologies. And this is a 1 over x minus x. Sorry? Yeah. Okay. So we do still need a common denominator. We're still going to have to do that. So we're going to have to combine these. So this is like x squared over 1. So what needs to be multiplied somewhere? What are we going to do? Yes, ma'am?
X squared.
Okay, on the right, we're going to need to multiply by x squared so that this one gets an x squared. So we get 1 over x squared minus x to the 4th over x squared. In the denominator, what do we need to multiply by? The right-hand one needs to be multiplied by x over x. 1 over x minus x squared over x.
Wait, what is dividing or multiplying?
We're not. We're making a common denominator.
No, like directly that you put next to the x squared.
This, we multiplied.
No, the top.
We multiplied. We multiplied the top and bottom by the same thing. Okay, so our common denominator is x squared, and in the top we get 1 minus x to the 4th. In the denominator, we've got x and 1 minus x squared. All right, so we're going to rewrite this. Every single time we're doing the same thing. We've got 1 minus x to the 4th over x squared divided by 1 minus x squared over x. Where am I going from there? Keep, change, flip. Okay, so this one's a little bit hard to see at first, so we have to just kind of take our time with it. There's a lot of things going on with this one. Yes, ma'am?
Are you allowed to do the difference of two squares when there's a one of that?
Yes, yes, because that's still a square number. It's still the difference, so it's still the difference, and these are still 2 squares. This is the difference. These are still 2 squares. So we actually have 2 sets of difference of 2 squares going on. Let's talk about the numerator in the upper left. What does that become?
One minus x
1 minus x
squared, 1 plus x.
squared and 1 plus x squared over x squared times x over 1 minus x squared. Now, this right here is the difference of 2 squares, and so is this. However, why am I not going to bother breaking them down? They're going to cancel out right now, so why not save myself time and go, let's get rid of them right now. Well, yes, that's where we're going next. Let's not stop what we're doing here. So we canceled these. We will do that next. So we canceled these 2 out because they're both the difference of 2 squares. They're both the exact same thing. Now, Matthew, what were you just saying?
You can cancel out the x squared with the x on top.
Okay, one of the x's up here cancels with one of the x's down here, leaving just one x in the denominator. Right? That x squared is the same thing as x times x. It's two x's in the bottom, so one of them is going to cancel out. In the top, we get 1 plus x squared over x.
In the top, you would do 1 minus x and 1 plus x,
Why?
because you still have the 2 as a component.
Because of what? Sorry?
Because, well, that's your answer?
Yeah, that's it. That's all we've got. There's nothing else to cancel out, so that's all we can do. Okay. We've got s squared minus 1 over t squared. Because it has a negative exponent, I wrote it as a fraction. Over s minus 1 over t. What am I going to do with the numerator? Common denominator. So what do I need to multiply by? The left one needs to be multiplied by t squared over t squared. So we get s squared t squared over t squared minus 1 over t squared. In the bottom, what do we do about a common denominator? Multiply by t. And we get st over t minus 1 over t. All right, combine those together, and we get s squared t squared minus 1 over t squared. Hold on one second. st minus 1 over t. Yes, ma'am? We shouldn't be doing any dividing until... Okay.
Why don't you multiply with an x?
Negative x?
No,
S?
yeah.
We need a common denominator. Are you talking about on top? There's no s in the denominator.
Oh, so you only divide what you have in the denominator?
Well, we're making a common denominator. So it can only be things in the denominator. Okay, so we're here. S squared t squared minus 1 over t squared divided by t over st minus 1. Let's talk about what breaks down, because there's actually two interesting things going on here. One's really easy to spot, the other one's not really easy to spot. What's the easy one to spot? What cancels? Oh, actually, I didn't rewrite this, did I? I'm sorry. I did. I made a mistake here. I rewrote it, but I didn't change it to... Here we go. Let me correct my error. st minus 1 over t, and then keep, change, flip. There we go. Okay, my apologies. Now, what's going to cancel out? Okay. Good. One of these t's is one of these, leaving just a t in there. Something else is going to cancel out, but why and how come? Like, how does it happen? This is the difference of two squares. The first thing is a square, and the second thing is the square. So let's talk about what does that break down into, because that's the hard one to see. Good. St minus 1 and st plus 1. And if you're not seeing it, it's because this is a square. St times st would be st squared. This is also a square. 1 times 1 is a square, and it's the difference of two squares. So we get st minus 1, st plus 1 over t times 1 over st minus 1. Cancel the st minus 1. And we get st, bless you, plus 1 over t.
The answer?
That's it. All right, the last two are exactly the same. So actually, I'm just going to jump on to the next lesson. It's just repeating the same steps over and over again. So I will post the solutions to those two for the notes, but it's the exact same process. There's nothing new. We're going to jump on to 4, 6.